Guys, welcome back to the channel. Today we will solve the daily Leetcode problem of March 13. It's a easy problem, and if you know arithmetic progression, I think this problem would be very simple. So let's try to read the question. So given a positive integer n, find a pivot integer x. What is this pivot integer? Is that x such that sum of all the elements from 1 to x exclusively it's equal to sum of all the elements from x and n inclusively. Okay, right. So these should be equal. If there is no such pivot integer, we should return -1. Okay. So if x was the pivot integer, sum of all the elements between 1 and x is x into x plus 1 total of by 2. Similarly, sum of all the elements from x to n. So how can we find this is this sum x to n is equal to, you can write it as sum 1 to 1 to n sum 1 to x minus 1, and sum to x to n implies x to n inclusively, right? So we can write it like this. So if we solve this mathematically, pivot integer condition as per the definition is sum 1 to x equal to sum x to n. So what we'll do is we'll equate them as per this condition. So this is the arithmetic sum 1 to x formula. This is just normal AP sum formula, right? You can check it later in case you haven't seen it before. So sum 1 to x is equal to sum 1 x to n. So sum 1 to x is x star x plus 1 by 2. Sum x to n, we can write it as sum 1 to n minus sum 1 to x minus 1. So sum 1 to n will have the product n star n plus 1 by 2, and sum 1 to x minus 1 will have x minus 1 minus 1 star x by 2. Basically the formula for 1 to x is x into x plus 1 by 2. So for the formula for 1 to x minus 1 will be put x minus 1 here and here, so we'll get x minus 1 into x by 2. So that's how we get this, right? So we can cancel the division of 2. So what we'll get is x star x plus 1 equal to n star 1 minus x minus 1 star x. Let's bring the x to the left hand side. So we'll get 2 star x equal to star n plus 1. So basically x is equal to square root of n star n plus 1 by 2, right? So if x should exist, technically x as per definition is a integer number. So this square root should exist. It should not be a what to say. It should not be a decimal number. It should be proper integer, right? That is the condition. If it's not a proper integer, we'll return -1. So let's solve it. To remember the to check whether it's a decimal or not, what we'll do is we'll define a double uh, capital N, which is equal to n, and we'll define another double answer x, which is equal to square root of n star 1 n star n plus 1 by 2, right? Now, how to check whether x has a decimal part or not? We'll define integer x, which is equal to this. So what this definition does is it typecasts this double variable x into x, integer variable small x. So what will happen is if there was any decimal part, I mean after the decimal point, all the value will be excluded. So now we can if now if double of x is equal to capital X, if the after decimal point if there was no numbers, I mean it was like say if capital X was 5.0, small x would be 5, right? If capital X was 5.67, also small x would be 5, right? So this condition double of x, we have casted the double type to this integer variable x. So what this will happen is we'll check whether 5.0 equal to 5.0 in the first case. The second case it will check 5.0 equal to 5.67 in this case. As you can clearly see, in the second case, if there was decimal value, this equality won't work. So if it was equal, we will return just x because it has no decimal value, I mean fractional value. Otherwise, we will return -1 because it has a fractional value, which means the square root is not a perfect square, right? So this is mathematically correct, and the time complexity is just the time spent to calculate square root, which is very small, I guess. Square root of n would be even in the worst case, I guess. For 1000 it doesn't even matter. So let's try to run it. Yeah, it works. Okay, let's submit it. Yeah, so that's how you solve this problem. I hope this makes sense. Just a arithmetic progression test problem. There's no data structure or any algorithm in it. Thank you. Let's see in another problem.